All right, so we'll start pandas, and so the way we import pandas is import pandas as PD. PD is the usual alias that we use, but it's up to you whichever the alias that you want to use, you can use it. So I'm gonna need NumPy 2 in some cases, and so we'll start with series and data frame.
So why is Panda used? I mean, purpose.
For data analysis, I think we discussed about this. NumPy is for numerical analysis and of course data analysis. Pandas is again for data analysis, but it is much more simple than NumPy. Matplotlib and Seaborn are for visualization. All right, so the next one is series. Suppose just like the way we have a list in Python, right? And we have NumPy arrays, right? In NumPy arrays in NumPy. Same way we have pandas series. It is capital S series. It's 1, 2, 3, 4, 5. Show you the output and then you can explain me what is the difference. This is X, I'm displaying it. This is of course array. We have complete history, and this is going to be my series. So what is the difference that you have found? It's the same thing. In Python, we call it list. NumPy, we call it an array, NumPy array, whereas in pandas, we call it a series. What do you think the difference between these three? Of course, ignore these two. So what is the difference that you find in pandas? Is there any advantage of series over NumPy array or list?
Maybe we can see data type and index number, something like that.
Exactly. So we get additional information. It is quite easy to interpret. Whereas in this case, if I want to fetch, let's take 4. What is the index of 4? It is 0, 1, 2, 3. Whereas in this case, it's right away 3. Isn't it? It's quite easy. So 3. You can get the index and of course data type of the whole thing. So I hope this is clear. So any questions on that?
No, sir. Understood.
And the next one is we can even provide the customized index. For example, if you look at this, we have index, right? So I'm going to use list comprehension. Let me so list comprehension. This is instead of manually typing it, so I'm going to for in we have 5 values here, right? So I'm going to go with 6. So output is not going to get included. This is going to generate int1, int2, int3 and all. So I'm going to store it as int or indices. So I'm going to pass this one instead of manually providing it here. I'm going to pass this as index. And if you look at this one, now we can get customized index. Now you can of course get the normal way of getting the values. Apart from it, in let's take int4 is int4, right? Int4. So we can give the even the name and get the output, but this is string. So we need to provide it like a string.
It supports multiple data type insertion, right?
It doesn't matter. It's we are fetching the value. But if it is multiple data type opposite, let's take that it's 4.5, that is going to overtake the float 60. I think NumPy we discussed about this in detail. The same concept will be applied to pandas also.
Okay.
Can we give series in again in one more series? I mean, earlier we were giving list inside a list also, right? Like that.
Then it is going to be difficult to get interpret. If you look at this, so it's difficult even to show. Even though you can see that it got an error. In pandas, it expresses the data it could in either one-dimensional or two-dimensional. And moreover, the series is basically for one dimensional. Of course, this is even having a nested series is one dimensional, but look at pandas as more like, the way you look at the data. Okay, don't expect multidimensional data.
Okay.
Fine. The next one is series with dictionary. Suppose if I have a dictionary, something like my dict 0 0 1 1 2 2 4 4 5. A dictionary like this, we can easily convert this. We can directly pass this dictionary and get converted to a series. So here by default, whatever the key that we have, going to consider as the index, and the values are going to be considered as the values. Suppose if I have something like 1, 2, or not to be just 1, it can be listed 11, 12, 13, 14, 15, and 16. You can see that we got corresponding things. Suppose if in this case we haven't created the series, right? So my series one, let's take 11. We got 0. So in this case, if you provide this thing, obviously it's good, there is ambiguity. It has overwritten the actual numerical indices. If it is string, that's fine, we can get it. But if it is numbers, it has completely overwritten the default index. So it's not going to work. So we need to provide the proper index, whatever the values that is displaying here, right? Any questions up to here?
No, sir.
Next one is data frame, which is a tabular form of data. So I'm going to take some random data, rand n. Okay, so 100 values. I'm going to reshape it. I think it has something like, no, I don't have. Okay. Can reshape this into 10 comma 10, right? So I'm going to store random data. So you have, so this is numpy array, right? So we have seen this. If we pass it to data frame, then it's going to provide, visually it's going to be much easy compared to this one, isn't it? So pandas frame, data frame simplify a lot of things. You can see that I'm going to store it in the form of variable called df. Here we have data frame. So the same thing, but indexes, you can see that, right? Of course, we can even customize this thing, like customize index and columns. Suppose index, I'm going to use the list combination to generate some values. Okay. So I in range 1 comma 10, right? So but 11, so outer bound is not going to get included. The same way I'm going to give columns also. I think it's column something. And I have not ended up properly. So yeah. Columns. It's better to copy the same thing, but instead of int, I'm going to give it as calls. Right? Call. Now, if you can see, we can even customize the index. The index, we got the index, and call, then we got the calls. Got it? So we can give a customer index and columns. That's the whole idea. Suppose if I need only the first 5 rows, I can use df.head. It's going to give the first 5 rows. By default, it's going to be 5. Let's say that I want first 7 rows. I can use 7 also. If it is 5, you can completely ignore these parts. By default, it's going to be 5. You can see it's here 5. N is 5. And the same way, head is going to give the first 5 rows, right? Same way, if you want to fetch the last 5 rows, tail. So like in the case of head, we have, it's by default 5. Let's say that you want the last 7 rows, then you can use 7. Right? Any questions on this?
What if we want to only index the columns, not the
Yeah.
rows? Right? So do we have to put only comma, and do we have to use that one?
Yeah, I will explain that in slicing. So in this part,
Okay.
I have not reached that point. Right. All right. So the first 5 rows and last 5 rows, and if you want to fetch all the column data types, right? You can use this one, dev data. In this case, I have taken only float data, so you got all the columns as float. But in real time, it could be integer, it could be string, object, or it could be anything else. So so it's a column and the data type of that particular column. That's how it is. So overall, the data frame is object. That is what it says.
Row wise, we cannot get the data types, or only the column.
What is the need of getting? No, how do you even get the data type of the row? What is the need of it?
I will store in the column wise, right? So yeah.
So the nature of the column that is important, right? Okay, so dev.describe gives the statistical information. So dev.describe statistical in the sense for each column, it's going to give all the statistical information, like count the number of values in that particular column. It has 10 rows, right? So it clearly shows that it has 10. And if you know, there is another one, dev.shape give us the number of rows and columns. So for because the column one has 10 values, we got 10. But if it has null values like n, a, n, then that will not be ignored. So here that will be ignored. I mean to say that will not get counted. Here we have all the values. We don't have any NaNs. But if in case it has anywhere you find in null values, that particular column count will get decreased compared to the total number of rows. And the mean of that particular column, standard deviation, I have not explained standard deviation, minimum 25th percentile, 50th percent. We call this as 25th percentile, not percentage, percentile, 50th percentile, 100th percentile, and max. I will explain this concepts later. Right? For now, if you understand the count, that is good enough. Describe will give statistical information for each column, irrespective of how many columns we have. Let's say that we have 100 columns. For each column, it's going to give the statistical information. Okay.
So what is count? Can you please explain again?
No, I'm not going to explain it again. So you have to be specific. So a repetition, I don't like to. So you have to focus on it. Sorry.
Yeah, okay. I'll look at the recordings.
Yeah. So I request you to be no. If you can ask a number of questions, I don't mind, but you need to be specific more. So if you don't focus, you have to. All right. So the next one is simple data frames without. We already seen this one. So if we don't provide this, if we don't provide in customized indexes and columns, by default the column name is going to start from 0 to how many number of columns, whatever it is, and we can give customized index name and column names, right? And if you want to from dictionary to data frame, we can do that. But if you want to fetch only the column names, columns, it will give the list of columns. In the same way, we have something called index that will list out all the index of that particular data frame. Okay. So any questions up to here? So the column names, I think from dictionary, I will explain that. So I have to take the dictionary. Looks like the data frame part. Yeah, here I have a dictionary. So here I have a dictionary. I can convert this. You know this better, right? We have discussed this dictionary in even in this one in Python. So this is basically a nested dictionary. So each key instead of value, a value is in fact another dictionary, right? Same way for 2016, we have another dictionary. If you convert this sort of data frame, kind of two-dimensional, two-level nested dictionary, it is going to give a beautiful data frame. you can see that all the keys being shown as the column names, whereas the nested dictionary, this dictionary, the keys of those dictionaries are reflecting as the indexes. And it has to match. If it doesn't match, let's say 33 I have written, and it's going to write, give another value altogether. But if you look at this closely, ID3 has RCB because we have ID3 RCB for 2015. Whereas for 2016, we don't have ID3, ID underscore 3. So what we got here is NAN, not a number. For null values, it's going to show as NAN. And the same way, we don't have anything called ID underscore 33 in this. So for ID underscore 33 for 2015, we got NAN, right? So I had given intentionally that that all the keys matches. Let me reset back. Any questions on this part? Of course, we can assign it to variable. We can apply all the methods like head, tail, whatever.
Do you have to give the key values same as the 2015 and 16, or it can be different to get this value?
And that's exactly what I have explained here. So I try to give 33 and shown you, right?
To get the tabular value, you have to give like this.
No, I think you completely missed it. So not to match, but here I have given a matching keys. But what if I don't have a matching key?
Yeah.
What's your name? I request
Naren.
you to, no, there is, you lack focus. I request you to focus. I clearly gave an example, ID underscore 33. We don't have any key called ID underscore 33 here. I intentionally gave it as 33 instead of 3. And here ID 3 is missing. Here we don't have ID underscore 33. So what we got here is NAN, right? So we don't have a, yeah, so when ID underscore 33 is completely missing here, it's showing as NAN null value. Whereas in this case, ID underscore 3 is missing, so we got NAN in the case of 2016.
So, sir, for first dictionary keys, it will take care the reference?
No, it's not like that. It's going to consider all the keys for each column basis.
Okay, at last
as it matches,
okay.
It is giving the values.
Okay. At last it came IT 33. Okay.
Fine. So we have seen the head, tail. Head will give the last first 5 rows. We can customize it. Let's take 7. We can get the first 7 rows. Tail will give the last 5 rows by default. We can customize this one too. Index will give the list of indexes that particular data frame has. And this one, df.columns will give the list of columns that particular data frame has. Shape will give what? Rows and columns, number of rows and columns. In this case, if I give some shape, it's going to give me 8, 2. 8 rows and 2 columns, right? And we have df.dtypes will give us data type of each column. So here in this case, object, which indicates that is a set of strings. df.describe will give us statistical information. So so here in this case, it's a set of strings. It is not going to match like the way we got for numerical data. Numerical data, it's going to be different. The set of statistics is going to be different. Whereas for categorical, that is string related, it's going to be different. So we will basically, this is unique in the sense how many unique values we have here. So if you look at this one, it is KKR, SRH, RCB, it's again unique, K11, Mumbai Indian, RCB again. So it has repeated twice. Out of 7 values, 1 value got repeated, right? Out of 7 values, 1 value got repeated means what? How many unique values we have? Out of 7, 1 got repeated. How many unique values we have? 6, right? So that's the reason we got 6. In the case of this one, we got only 5. Why do you think that we got only 5? 5 unique values. SRH, KKR.
RCB repeated.
KKR repeated twice, right? KKR repeated twice. And what else has been repeated twice?
RCB also repeated.
RCB, yeah, here we got repeated. So out of 7, 2 got repeated twice. So it is 5 unique values. That's the reason we got 5 here. And what is the most frequent value that got repeated in those columns? That is 2015, 2016. So in this case, it is RCB repeated twice and KKR also repeated twice. It is going to take the last value if it is same. RCB twice, KKR twice, so it's going to give RCB. The last one repeated. Whereas in this case, it is only one, right? I think it is RCB. RCB. So we get RCB as the mode. This is mode, top. Frequency is how many times this got repeated max. This is twice. And KKR also twice. Suppose if I have written something else like another KKR, then let's take this one RCB. Here I'm going to write as RCB. So statistical information give us 3. You can see that in 2016. I have made modification in 2016. Right? Any questions?
No, sir.
All right, the next one, we can change, we can even change the column names. Suppose I'm going to take this data frame. We have some bunch of column names and indices, right? Suppose if I want to change the columns, basically the way we need to fetch the columns is what is the what is the formula? I mean, it's not formula. What is the property? It is columns, right? To get the list of columns. And what about index? Df dot index to get the list of indices. Suppose I want to change instead of small call, I want to change maybe like I wanted to write it like COL, capital COL. I mean to say I need this part in capital letters. I can use list comprehension. Okay, like the way in the case of the previous one. So for I in range, how many columns we have? 1 to 10. So 1 to 10, but outer bound is not going to get included. So 1.
11. Yes.
Yeah. So this is, I'm going to store it in a list called calls. And to this df dot calls, if we assign it back, it will get changed. Sorry. Right. So this is calls. If you check now, df data frame, it is in cap letters. It doesn't matter what we write. In fact, let's say column might got change, isn't it? Or maybe column underscore is much better. The same way we can change the indexes also. Now you need to tell me what I need to do to change the indexes, index names. The same pattern.
We have to assign index or capital str for.
So,
Then we have to df dot index is equal to that variable we have to assign.
So we have the same number of indexes also. So we can stick with 1 to 11. Based on the number of values we have, number of rows, we need to give the range. So in this case, rows, right? Sorry, indices, right? I like to give a more appropriate name. So in the same way we assign this one. So we have something called index, right? And we can assign this to here. And if we check cross data frame, you can see that we got the index. I mean, here I have taken list comprehension, doesn't mean that you have to take the same thing, but you can even give it manually, like, yeah, ind underscore 1 or in, like this. You can even do it manually. I use list comprehension to automatically generate irrespective of how many rows or columns we have. So don't get confused with that. Yeah, go ahead.
Individual rows can also be named, right? That's what you're telling.
It's not rows, in fact, it's the index.
Yeah, index.
Index of those rows. Yeah. All right. So any questions? I think this is clear. Next thing is simple. Just like the way we have transpose. What does transpose do in NumPy array?
Reverse the
It will
reshape
change
like
the
5 to 4.
Row to column.
Yes,
Row
rows
to
to
column.
columns and columns to rows.
Row.
The same way we have transpose capital T that converts rows to columns and columns to rows. Okay. That's a very rare case that we use transpose. We're not going to use it unless the data comes in a way that rows being represented as columns and columns being represented as rows, and we load the data and we need to transpose it, so we can transpose it. Otherwise, we can, usually the data comes in proper form. All right, the next one is very, very important, slicing. If you understand slicing in NumPy, it's quite easy. So anyone practice slicing in NumPy? Anyone has that is clear, it is quite easy. I'm going to go with the data frame. Now, let's say that I want to fetch this particular chunk of data, the slicing part, okay? Only this part. So now you need to tell me, okay, the same way that like in the NumPy, we have something called a row slicing and column slicing. Okay, so before even getting into that, so to fetch this data from which row to which row and which column to which column, we will decide that first. Okay, instead of inserting and getting confused, it's better to sort that first. Yeah, you need to tell me. So look at this data and tell me which row to which row.
4, 6 rows.
This is fourth row, right?
4 to 6.
Fourth row. Fourth row.
6.
6. 4, 5, 6. Okay, what about columns? Looking from here.
4 to 7. 4 to 6.
Again, this one is also 4 to 6, coincidentally, but not we seen, right? Based on that, based on the data we have, so we need to. So now,
Sir, it should be +1.
Yeah, that is when we insert it. But right now it is literally fourth row to sixth row, fourth row to sixth row. But when we insert it, we should not mention 4 to 6. It is +1. The same way, we need to mention the column slicing, right? But if I exclude this, it is going to throw an error. The reason for that is in NumPy, yes, we can right away mention like this. But in data frame, we need to add ILOC. I stands for index. Okay. So if I execute this, I get the data. It is not matching. Okay, the fourth row is actually this one, right? So it starts from 1. So the fourth row means what? A third.
Third.
3. So I think we completely went wrong. So yes, 3 to 6 and 3 to 6. Now we got the required data. Okay, so now you need to tell me that I'll give one, like I think you need to unmute yourself one by one, and you need to, let's take I need this sample of data. Now tell me. So first decide row slicing and then column slicing. First rows first, and then we will go to that part. Yeah. So based on this -1 point from where? This one, right? Yeah. Now tell me. So Sirisha, let's start with you. So I need this data starting from, I missed that again. Yeah, here.
-1 point. Okay.
So rows, I mean, from which row to which row?
1 second, rows. That is fifth row, but you can mark it as 4. For slicing value, it will be 4 colon.
We'll write as no. We'll
Okay.
write here as 5.
Okay. 5.
Up to what is the max row? So fifth row to
10th.
all right. So
Sorry,
10th row.
10th row. Yeah,
10th only. Yeah. What about column slicing from here?
7th column to 10th column.
7th column to 10th column. So here we need to mention. So 5 means 4.
4 to 9.
4 to 9. Okay. So what about column slicing?
6 to 9.
6 to
9.
11, right?
9. So here this is the index starts from 1 to 1. So it's 6 to 9. The index starts from 1 to 10. But the Python index starts from 0, right? So it's going to be 9. Okay, your point is, yeah, +1, right? Here, even here, it's +1, isn't it?
Oh, okay, yeah.
Okay, got it. I think he's right.
Yeah, correct.
I'm wrong. Now we got the required data.
Okay, yeah, correct.
Okay, who is next? Naren? Let me take some chunk. I need this data. And I'm going to mark
3 to 6.
3 to
6. True.
3, 4, 5, 6. All right. So 3 to 6, 3 to 6. All right. Next one. The columns.
3
Let me show you.
to
Yeah, it's here, right?
3 to 7. 3 to 7.
3 to
7. Yeah, 7.
yeah, it's 3 to 7, right? 3 to 7, right? So what about the index? It
2
starts 2.
to 6.
Perfect. Next one, column slicing.
2 to 6. 2 to 7.
2 to 7. So outer bound anyway, not
Yeah.
to change this one. So that's quite easy. So we got the data. And who is next? Naren, Piyush. So
Yes.
let me give the data to you. For example, I need only this data. Now you need to tell me. So row slicing first and then cost.
Yes.
So look at the rows.
It is from row 5th to
5th to
last. That 10th, I think.
last
10th.
10. So what I have taken? So point. Okay. Don't give any hints. Let him answer on his own. So only these two. Okay. This part I need.
Oh, okay, sir. 6th. 6th.
Yeah, it's a 5 to 6.
6th.
What about columns?
Column is from
1 second. Let me mark it. Even I'm losing the data. Where is that? Yeah, here. So what about columns? How many columns? From which column to which
6th
column? 6th to?
to 10th.
All right. 6th to 10th. 6th to 10th. So then what will be the index then?
That should be 1 minus, that is 4.
What? Okay. Oh, yeah, I got it. 5 means 4. Okay. 4
4,
colon.
4 to 6.
Right. And what about this
And
one?
this should be 6 to 9.
It's actually 5, right?
5.
5 to 10, right? Even though
10,
it's 5 to
yes.
9, but it's actually 10. Now we got the expected output. All right. So any questions up to here?
So if we don't mention the outer bound for the columns also, we may get the value, right?
Yeah, in this
Because it
case,
is last.
yeah,
So
in this case, yes, that's true. Because we're going till the end, right? So we get that output. The same logic applies for pandas also. The same thing for rows also. So if you don't mention it, you're going to get till the end. Let's take that you have 6. And if you want things from start, then you can ignore that part also. Right. So I'm going to go back to the same values, right? 5 to 10. So right now we can only provide the index, right? But we have names here. If you want to provide the names, then you need to use lock. So we should not use ilock. Suppose if I need values from 1 to 6, then I need to provide the names. Index 1, okay, index 6. Here, if you provide names, in the case of lock, if you provide names, the outer bound is not going to get excluded. It is going to get included. If I exclude this now, of course, I have to change this one. So 5 means what? So column 6, right? And 10 means column 10. Of course, the last part, if you want to go till the end, even in the case of lock, we can ignore that. Got it? Even here we are getting from start, right? We can ignore this part. So we get the same output. But if you want to give the names, if the index has any names or column has any names, then go with lock. If you have only indexes, or if you want to, even if you have names, if you want to go by index, use ilock. In this case, if I have, because I have names, if I use ilock, it doesn't work. Got it? The difference
Yes.
between lock and ilock.
Yeah, got it.
If you have combination of this, let's take here we have numbers and here we have names, we should not use lock. I mean, in that case, you can use lock. For example, if I use df.index, right? So I'm going to reset it like I for I in range 1 comma. How many rows we have? 10 rows. Okay. So I'm going to reset it with default 1 comma 10. Or maybe I will do one thing. So I will ignore, simply mention. Yeah, okay, go ahead. So these are numbers, isn't it? So in that case, I can use numbers. There's nothing wrong in it.
Last bond will be included or excluded even while using the numbers.
Can have, because we have numbers. Yeah, no, the outer bound is not going to. Yeah, here it's actually it's literally taken as strings. It is giving the value, but let me go set it back to the normal index. Mm, So, it's 10. I think it is literally taking in the form of this thing. What I do is this, yeah, here it is. You can see that it is going
Included.
up to us. Yeah, it's going to get it. But I will do one thing. I will reset right at the this thing, this part. Here I'm going to completely remove the index part. Right, data frame we have, and then we will execute this part. So let's see. This is lock. You can see that it does column 6. Okay, I think the by default we have changed it later, right? The column names we have changed it later. So I think that was deleted. I will do one thing. So instead of I will say call, right? Call call 6. You can see that it has included. The lock is always including. That is one problem that we see. So better not to combine both, but it's better to use ilock rather than lock. Anyway, any questions on this lock and ilock and how to slice the data frame?
No, sir.
Suppose Boolean indexing. So here we have a data frame. It's an interesting case. I'm going to have a dictionary. We can convert this into data frame, right? Here we have a data frame. Suppose if I want only this particular row C, then we can do that. That is df id column, right, is equal to C. That is a condition. You can see that it only here it got true, the remaining also false. So we can pass this just like the way we have it in NumPy. We can pass this and get only that particular set of values. For example, let's take, I'm going to take another one. So val, I'm going to apply it on val column, right? But here I have applied it on the whole thing. So suppose if I need only ID column, we can get that. Suppose another case where the val should be greater than or equal to 5. You can see anything that is less than 5, it is showing as false, right? This condition. If I pass this condition to this one Boolean values, you can get see only that has values greater than or equal to 5. Isn't it? So any questions on this Boolean indexing? How we
No,
apply
sir.
Boolean
Can you please
indexing?
go up that one? Dict. Yeah. Dict. So is this the different way of defining a ID and value
No,
or
we
key
have
value?
already no, we have already seen that an example how to convert dictionary to data frame. So this is a dictionary, and we converted this dictionary to data frame.
Okay.
What is okay? So we completed
Sir,
up to
sir, frame and table structure means it is showing the table structure.
same.
It is both the same or?
Yeah, in pandas we call it as data frame. That's all. It's tabular data. That's
Yeah.
all right. So we will continue tomorrow. I think this will take some time rather than continuing now. So we'll continue tomorrow. Okay, that's it for today. So practice as much as you can so that the other concepts that we discuss, you're not going to have any difficulty. I request you to practice right on the same day itself rather than postponing things to weekends. Okay.
Okay. Sir, please upload this.
That will be done by institute. So it's not in my hands. So they will do that. You
Google
can,
Class also. That
in the Google Classroom, I don't know whether I have uploaded scripts or not. So I have to upload scripts. Scripts part I will do it, but when it comes to video, they will take care of it. The institute will take care of it.
Yes,
You need to
that
contact.
is they end of the day they will upload because
So if it get delayed, you need to contact them. So it's not in my hands. In fact, I don't even have access to the videos.
Okay.
Yeah. Thanks.
thank you, sir.